Hi, my name is Jade.
And my name is Fernanda.
In this video, we'll walk in a practical experiment using the STM32F411 RE microcontroller to control an LCD display. We'll go line by line of the code, so we begin.
Okay, so first in our code we need to include two headers, which are these two basic libraries. The first one allows us to use standard integer types, and the second one, which is the STM32F4XX header, gives us access to all the STM32F4 registers and definitions. This is a library that we need to install. Next, we're going to define constants for the LCD control lines. RS, RW, and EN are connected to the pins PP5, PP6, and PP7 respectively. Now these hexadecimal values set individual bits in the GPIO registers. And then we have our variable unsigned char. This is a message that we will display on the LCD.
Okay, now for our main function is this one. And here we simply initialize the LCD and then enter an infinited loop. No further logic is needed because the message is displayed once and doesn't need updating. Then we go for this void function. Here we configure the GPIO ports. We enable the clock for GPIO-B and GPIO-C by setting bits in the RCC AHV1ENR register. The first one means enabling the GPIO-B and the GPIO-C. This second function sets the port V5, V6, and V7 as outputs. Then the third one sets EN and RW low by using the reset part of the BSRR register. And finally in this, we set the port C0 to port C7 as outputs. These are used for data lines D0 to D7 of the LCD.
Next, we have another void function. It's the LCD command function. This sends a command to the LCD. We set RS and RW low. This means we're sending a command. The command is placed on the data bus, which is pins PC0 to PC7. Then EN is toggled high and then low to latch the command into the LCD. And finally, we included as a commenter a short delay that is used to ensure timing.
Now, also we have another void function. In this function, we send data as a character to the LCD. RS is high and RW is low. This means the data mode. Data is placed on the GPIO-C data lines, and EN is pulsed again to latch the character into the LCD. We add longer delays here to make sure the LCD has enough time to process characters.
Then we have another void function. That's the LCD initialization. Here we configure the display with standard initialization commands. For example, selecting one line is a two-line display. We have a 5x8 font and an 8-bit font. Next, we put the display on and the cursor off. And after that, we are moving the cursor to the right and then clearing the screen. And after that, we move the cursor to the beginning and display each character from the message array, as we're going to see in a video later.
Finally, we have the void function for delay, and it's practically a basic software delay. It's good enough for simple experiments, and the inner loop just wastes time to create a delay in milliseconds. So this is how the code goes, and we're going to show a video of how this works in the board.